This video shows the process of commissioning the experimental lysimeters at the National Green Infrastructure Facility, Newcastle University. This work is being conducted as part of the EPSRC funded project, Urban Green DaMS. Phase 1 of the Urban Green DaMS lysimeter commissioning involved filling the 4 lysimeters with a graded drainage layer made up of a 4 to 40 mm aggregate and a transition layer consisting of a 2 to 6 mm aggregate to prevent the migration of fine sediment through the engineered soil profile. Land drain piping with a diameter of 60 mm was fitted within the drainage layer in a herringbone configuration and connected to each of the lysimeter cell's outflow units. The outflow units were fitted with 2 tipping bucket flow gauges to measure outflow discharge. Each of the lysimeters are split into 2 separated cells. Cell B is free draining, whereas Cell A is restricted with a geotextile placed before the tipping bucket flow gauge to slow the outflow discharge to achieve greenfield runoff rates, making better use of the full soil column depth for water storage. Phase 2 of the lysimeter commissioning involved filling the lysimeters with a suds substrate and instrumenting the lysimeters with a series of sensors to measure key hydrological variables within the soil profile. The suds substrate was filled to a depth of 700 mm above the surface of the transition layer to complete the 1 metre engineered soil profile. An area of ponding depth above the soil profile was incorporated into the lysimeter design to allow for any additional surface water ponding following natural or simulated extreme inflows of precipitation. Surface water outflow units were built into the lysimeter liners to collect and quantify any ponding water depth at the lysimeter surface. Each of the Urban Green DaMS lysimeters are instrumented with over 50 sensors and instruments. These are connected to a GP2 data logger which takes measurements every 5 minutes. In total, all 4 of the Urban Green DaMS lysimeters output over 150 measurements every 5 minutes, which are available in real time on the National Green Infrastructure Facility API. The lysimeters are instrumented with the following instruments: an E-tape water level sensor placed within a slotted pipe enclosure. This measures the ponding depth of any surface water within the restricted outflow lysimeter cell. This instrument only records when water is ponding within the lysimeter during or after high intensity rainfall events. Each lysimeter cell also has a soil view moisture profile sensor fitted within the centre. This records volumetric water content, electrical conductivity, temperature and permittivity at 9 depths. Each of the lysimeter cells are also fitted with a network of 5TE sensors to complement readings taken by the soil view. These are based within the transition layer and also in the suds substrate. The 5TEs measure volumetric water content, electrical conductivity and temperature. These have been placed strategically within the engineered soil profile to understand spatial changes and trends, both at varying depths and distances from the runoff simulator. Additionally, a T8 auto-refilling tensiometer was added to the restricted outflow cells of each of the 4 Urban Green DaMS lysimeters to record soil water potential and temperature. This was placed at a depth of 30 cm, in line with one of the soil view measurement depths. As well as measuring variables within the soil profile, a tipping bucket rain gauge is fitted on each of the lysimeters to record inflow precipitation. The rain gauge contributes input data to the inbuilt runoff simulator program, which provides simulated inflow to the lysimeter cells. This was built for 2 reasons. Firstly, to top up lysimeter inflow to simulate additional catchment runoff from surrounding areas, and secondly, to facilitate a series of design storm events. This is useful so we can understand the hydrological performance of suds under a variety of weather conditions. Following sensor deployment, each of the lysimeters were planted with different vegetation configurations. Vegetation configurations were the same in each lysimeter cell pair. An unvegetated lysimeter serves as the control, allowing the role of the suds substrate to be isolated from the vegetation. This helps to determine the relative contributions of evaporation and transpiration. The second lysimeter features amenity grass, typical of bioretention systems such as swales. This requires little maintenance and will help to establish the validity of the Penman-Monteith estimations within SUDS features. The final two lysimeters feature low-density shrub and dense canopy planting styles intended to provide differing levels of evapotranspiration performance. All of the lysimeter data can be downloaded from the National Green Infrastructure Facility API. To find out more, please contact green.infrastructure@newcastle.ac.uk or connect with us on social media.